Video is a quick refresher on inequalities. It does assume some background in inequalities, so this video is not intended to introduce the symbol and the vocabulary for the first time. I do want to cover what the symbol means and how to read it, and this lesson is only going to use positive numbers for clarity about the inequality symbol, but everything that we cover in this video would apply to negative numbers as well. I wanted to make this video because I see a lot of my students with a lot of misconceptions and a lot of discomfort with inequalities. And often by the time they're in high school, they are a little embarrassed to ask what it means because they think that this is something that they should already know from grade school. And I think it's valuable to have a video to clear up some of the misconceptions. I have seen inequalities taught in a way that was confusing even to me. And so I do understand if maybe you've seen some instruction on inequalities that is really, really confusing to you. So let's start by breaking down the word. So we have the prefix in, and in is one of many prefixes in English that are a negation. So it means not. So I'm sure you can think of a lot of vocabulary words where if you put in front of the word, it means not that. And then we have the equality, and equality would imply some kind of equalness about it. So when we put that together, the word inequality technically refers to any relationship that is not equal. Now, technically, this also includes this symbol right here, which is an equal sign with a slash through it, meaning not equal. But usually this is not what we mean when we use this term. So occasionally, when we're talking about inequalities, you will see this included in that. But generally speaking, that's not what most people mean in most lessons when they're using the word inequality. But I think it's important to note that, yes, that does fall under the umbrella of inequality. So what do we mean? So what symbol do we use? It's one symbol, but it's read two different ways. So the symbol is this, okay? It's like a angle, okay? And you've probably heard analogies like it's the alligator mouth, or it looks like an L, and it can also be flipped around the other way. So the first misconception I want to clear up is that those are two different symbols. They are not two different symbols. It's just one symbol, and you read it differently depending on which way it's pointed. So you probably heard this. I know I heard it growing up, and I think it's still used, is that think of it as the alligator mouth, and the alligator is really, really hungry. So the alligator always goes for the greater and leaves like the less behind. And if it's this way, then that means the greater quantity is over here and the less is over here. And what I've also heard is if you're looking at it this way, this looks like an L, like it's a tilted L. And so if you read it this way, then you're going to read it as a less than, because that sort of looks like an L right there. And all of that can help, but it's kind of a Band-Aid put on really understanding what the symbol means. If you understand what the symbol means, then you won't have an issue with reading it the right way. So let's look at an example with just numbers. So for instance, I might have 1, and then I have my inequality symbol, and then I have 4. And I would read that as 1 is less than 4. And the reason I'm reading it as less than is because when it's the inequality symbol always points towards the smaller and opens to the greater. So this would be 1 is less than 4. Now I could take the same relationship and I could write it this way, and then I would read it out loud. 4 is greater than 1. All right. Now, note that if we read the expression from right to left, we'd get the other expression. And I think this might help a little bit. So we don't normally read from right to left. Normally we read from left to right. So we would say 4 is greater than 1 because the inequality is pointing this way or opening this way. And we know that this is always the bigger quantity. But watch if I were to turn it around and read it from the other direction. So we have 4 is greater than 1. But if I go this way, I'd say 1. And now look at the fact that the inequality is now pointing at the 1, which means this is the smaller quantity. So we would say 1 is less than 4. Up here, we could say 1 is less than 4, but if I turn it around and read it the other way, I would read 4 is greater than 1. So it really is just one symbol that you can flip whichever way you want, depending on which quantity is the greater quantity. Now, how does this work when you start throwing variables into the mix? So if I were to read this out loud, if I look at the way it is oriented there, x is on the open end of the inequality, which means it is the greater of the two. And that means x is greater than 5. So if I use a number line, which is one of your best friends in math, okay, x is greater than 5 means that x could be anything on the right-hand side of 5. Now, it's greater than 5. Now, I want you to notice about this. If I have 5.00000001, okay, that number is technically greater than 5, but it's really close to the 5. And no matter how close I get to that 5, I could get a little bit closer. And so what we need in terms of our picture here is a way to indicate that we can get infinitely close to that 5. So what we do is we put a circle on the 5 itself, but we keep the circle unshaded, meaning we're not coloring the circle in like we are the rest of the possible solutions. We get down to that circle on the 5 and we leave that open, and that means nope, not the 5. The 5 is not included, but anything that is greater than 5 would work. But what about this? So then we start messing with our inequalities and we start putting this little line underneath it. Now, what that line is if you were to take the greater than symbol and marry it to an equal than symbol, okay, you would get the greater than symbol with like the bottom part of the equal sign underneath, okay? So what this is greater than or equal to. And what it means is that we are now going to allow for equality to also make this expression true. So in terms of our number line here, we have the 5, and we have anything greater than 5, or it could also be equal to 5. And so we do the same thing where we put the dot there, but this time we color the dot in. And what that means is that 5 will also work to make this expression true. It's including the boundary. So in both cases, the 5 is a boundary for the inequality, but in one case, the boundary is included, and the other case, the boundary itself is not included. And we show that by shading it or not shading it. We always shade the stuff that's included, so we just go ahead and shade in that dot. Let's take a look at one more example. This is what's called a compound inequality. And so if I read this from left to right, it would read 2 is less than x is less than or equal to 8. And just like the inequality appears, our x value is sandwiched in between the 2 and the 8. The 2 is not included, okay, because x, like if we do that little trick where we read it from right to left, x is greater than 2, but not equal to the 2, and x is also less than or equal to 8. So what does that look like if we were to sketch it out? So we got the 2 and we have the 8, and x could be anything in between, okay? So the 2 is less than the x, and the x is less than the 8, but the 2 is not included. So we're going to put that open circle, that unshaded circle at the 2, just to indicate that we can get closer and closer and closer and closer to that 2, but we're not going to actually hit the 2. But over here at the 8 is included. X could be equal to 8, and so we color it in over there. So that's called the closed circle. And really our value of x could be anything in between. So our x could be anything from 2.0000, like really close to that 2. X could be equal to 4 or 5 or 7.8 8, and x could be equal to the 8 itself, because the 8 would be included, and x could be any of those things. So we shade them in on the number line. Now, because I'm a big fan of knowledge, and I will often offer my students bonus knowledge, like that's what you get for coming to school today, you will sometimes see this interval denoted like this. So a little bit of vocabulary. That's called an interval. Okay, and denotion has to do with the way we write it. The way something is written down. And so you will sometimes see that written like this, with a parenthesis, a 2, a comma, an 8, and then a bracket. And what that means is that it is the interval from 2 to 8. The parenthesis is the way we write that the 2 is not included, and the bracket is a way of indicating that the 8 is included. And as you continue in your math journey, you will see that notation more and more frequently. It's typically not required at the early stages of doing inequalities, but it is kind of a neat piece of bonus knowledge. So as always, please give this video a like, subscribe to the channel if you thought that this was helpful, leave me a comment, let me know what else you would like to see videos on.